Alright guys, so basically we're going to have a snowstorm on this Sunday, which is January 19th, and this will be mainly in the evening hours in the northeast. So let's get into it. Right now this piece of energy over here in the west is the energy that will become our storm if we want to watch how this progresses from 1 p.m. Eastern today. If only this would work. Yeah, there we go. Alright, we are back in business. Alright, so basically now we got our energy coming down, digging down along with the cold air coming with this trough. We see very low 500 millibar heights out here, like 510, 504, touching Minnesota. And then look at this energy over here. It really starts to consolidate over the Mississippi Valley into the Virginia area. And you see how this consolidates over here. Pretty strong trough, kind of like a hose of vorticity over here. Good enough to have surface load development off the coast. Now, if we just want to look at 54 hours, we want to look at the comparison between the models. Let's pull that up real quick. And there are differences. I will tell you beforehand, the biggest difference compared to the American solution, which I was just showing you, is the European and the Canadian. So let's just look at the European real quick. The European has something that on paper looks incredibly similar to the GFS, but look at what's happening over here. This would load up properly. You see how the GFS is a bit more progressive, a bit more towards the negative side with this trough, and much further, not much further, just a bit further to the east compared to the European. You see the European is lagging a bit, is a bit further off this way. That's one of the differences. And if we look at the Canadian model is just a whole lot more northwest. And now, on paper, the European and Canadian look quite similar, but if we're going to pull out the surface maps, which I'm going to show you very soon, we can see they're pretty different. Let's just look at the AI solutions real quick, just to see if there's any matching. We can see the GFS AI model is a bit further west, a bit more in line with the Canadian. And the Euro AI model, honestly, I don't really know what this is doing. Very weak. Probably looks like an outlier. The icon actually is pretty similar to the European AI, except for the fact that it's a bit more strong with that piece of vorticity, so more in line with the European. The NAM model honestly has been looking like an outlier for quite a while with the storm, but it's starting to come up with something. And let's look at the RAB model real quick. Northwest, just like the Canadian. Alright, this is the Canadian regional, which is pretty similar. UK Met is more in line with the GFS solution. Alright, now let's get into surface maps at this time. Just standard surface precipitation type and rate, along with the low pressure centers. So if we look at the GFS, this is the time the storm is pulling away. Let's go a little bit further back in time to I think this is not gonna work. Yeah, let's go back to where we were at Sunday 7 p.m. Look at the let's just look at the difference in where the storm is positioned. We see over here it's off the coast of Long Island in the American model, which is pretty far off the coast. The track would have been something like this, meaning that I-95 corridor getting some decent snow out of this. Now we look at the Canadian. Look at that. It's lagging. It's much slower. B, look at that rain snow line. Rain snow line just to the north and west of I-95, which is basically making everybody miss out on that. Like the majority of people living along that corridor missing out on the snowfall. And let's look at the European. This is what I was saying. European is just mad weak. I don't know what it's doing, to be honest. This seems like quite the outlier. And I just don't think it is the case looking at the Canadian's GFS. Canadian's been on this storm for like forever. GFS has been fluctuating between a storm and no storm. But whenever it's been having a storm, it's been giving I-95 snow. European is pretty weak. The 18Z run of the European is out, but I'm not able to see that as it is behind a paywall. So I'd imagine the OOZ run would probably come to meet the Canadian or the American solution. Let's look at the icon. The icon is similar to the GFS solution, but a bit slower. NAM is actually finally starting to come up with something. Before it was looking like the European, but even weaker. But the NAM is also is a little bit closer to the coast than GFS, I think. No, it's actually a little bit further off the coast, but with the rain snow line looking similar to the GFS. NAM 3 kilometer. This is basically almost the end of its range, but it's depicting snow over the I-95 as well. RAP model, it's much more faster, even compared to the GFS. The RAP is the fastest out of all these models, but it actually takes a similar track to the Canadian models I'll show you pretty soon. A Canadian regional basically in line with the Canadian global. UK Met is kind of in between the GFS and the European in the fact that it's weak, but it has similar positioning to the GFS. So still at least some snow out of that solution. I'm thinking right now GFS solution is what looks likely as it's been like in between the European and the GDPS. But looking at the RAP run that just came in, the RAP just got in the range with the 21Z run with this. It is northwest, just like the Canadians. So I think we have to watch for this northwest trend. All right, now let's get into just showing you what the um, American model wants to do with the storm. If we just look at, actually, let me just pull this up on Tropical Tidbits so it can load up faster for you guys. So we want to look at what the American model is taking. It just takes a storm, and bang, look at that. Snow all up the I-95 corridor. And this is some decent snow as well, so it's nothing too shabby. And then it intensifies over the northeast area, so even heavier snow in areas like Massachusetts, New Hampshire, Maine. Now let's compare this to the prior run. Prior one is run pretty similar. The run before that pretty similar. So GF has been kind of stable in past 3 runs on depicting this storm. All right, let's pull out the European real quick. Again, this is 12Z run. 06Z run also very weak. Run before that also very weak. Run before that weak. So this has also been trending very strong. It's not even been trending. It's been stuck with this weak pattern as well. Whereas the Canadian has been also like it's been sticking to this northwest pattern. That's the thing here. One of these models is going to have to give in to the other models if you want to think of it in that sense. They're both showing 3 different solutions, which they have been steadily showing for the past at least a day and a half. One of them has to trend in a certain direction, or 2 of them more so. And yeah, look at the Canadian over here. Basically just takes a further northwest track, which basically robs I-95 of snow, but gives the interior heavy snow. Whereas the European is just like out to sea pretty much, honestly. Like this is nothing on it. Well, it's not exactly out to sea, but it's just like a 1 to 3 inches, which isn't very significant. All right, let me show you the RAP model, which has just come in an hour or 2 ago, and then we will get into snowfall forecasts and what I think will happen. So the RAP model is very important because it's a very high resolution model in the sense that the temporal resolution is high, not so much the kilometer resolution like the spatial resolution, but rather the temporal resolution. It comes in every hour, and it has hour by hour resolution in predicting, and it has very good data assimilation methods, and for that reason the data that it assimilates in is very accurate. It gives it a very accurate starting point, so generally the model is very accurate. This is all the way out to the end of its range, out to 51 hours, but I still think it is worth taking a look at and showing you what the RAP model is doing. So first of all, we saw before the RAP model is incredibly fast, and it brings in the storm around Sunday as early as what would this be? This would be around 10 a.m. Eastern, as early as 10 a.m. Eastern snow is starting, whereas most of the other models have it starting in the afternoon. And what the RAP has is that it has a battle zone. I think just to the northwest of I-95, I would say, is this battle zone, or along I-95 in some cases, like down here in DC, where it has sleet going on because of a 850 millibar warm nose. If we want to take a sounding, look at what that's saying over Somerset County area. Look at this warm nose around 850 millibars, and just above that, we can see that we're getting something poking in there, which could lead to some mixing issues if we have a northwest track as this is depicting. You can see the low pressure goes over land, goes over Cape May, meaning that coast would basically just get rain out of this. And the heaviest snow would be confined to northwest areas of Jersey, Poconos, and interior northeast. We want to look at the snow totals out of this. I mean, the storm wouldn't be done, but just look at potential totals out of this, taking into consideration the sleet that would cause compaction. I think that's what the internal model snowfall forecast does. this is what we'd be looking at. We'd be looking at along that sleep battle zone, 1 to 3 inches, and then north of that 6 inches plus, and potentially in some areas it's pointing out the Catskills with this northern track, potentially close to a foot of snow. Now, let's compare this to other models. Remember, that's not the entire duration of the event, so that isn't an accurate representation of what would fall. But let's just take a look. Just for the model's sake, let me just show you the European in its depiction of what's going to happen. It's not very much, but I guess I'll show it to you guys. It's thinking 2 to 2.1 in the 10-to-1 ratio, so I think that'd be translating to maybe 3 to 4 in the cold areas in this area, so not much at all. Now, if we want to look at this in the Kushera ratio, let's look at all the models now, except for the European. Look at the GFS. This is some pretty good snow, I would say. Widespread 7 to 8 inches, I-95 and northwest, and into the interior northeast. After that low strengthens, after we get some good frontogenesis going, 12 inches plus is what it's saying over western Massachusetts. Even getting into areas like Lexington, just northwest of Boston, saying a foot. Now, again, don't take these locations as set in stone. It's definitely going to change, but this is the idea. If we get that track to be just off the coast, not too far like the European is saying, just off the coast, like the GFS is saying, we're going to get some good widespread snow I-95 and north, potentially 6 inches plus. Now, if we look at the Canadian, look at how much further northwest Canadian is. Here, I'll just show you that change right here. This is Canadian. This is the American. Canadian, American. Canadian, look at that. Just this rain along the rain snow line, 1 to 3 inches. North of that, 8 inches widespread pretty much. And it's saying interior 12 inches plus. That would be due to the amount of cold air that's coming in from Canada with this cold blast that we're going to be having. So high snow to liquid ratios. So in this case, this would be quite. It would be a decent snowstorm for interior, but I-95 basically nothing, and even areas north and west I-95, you're gonna have to get into more of the mountainous terrain or more of the interior terrain to get decent accumulations. Icon is kind of a middle ground, I would say, in between the Canadian and the American. Except for it's a little bit weaker overall, saying maybe 2 to 4 inches I-95, and then northwest maybe 6 to 8 inches. The NAM is actually, honestly, I don't really like what it's showing with the snowfall forecast, but it's kind of similar to the Icon if you want to put it that way. If not a little bit more northwest. RDPS is basically just in line with the global version, except for maybe a little bit heavier, but that's just due to the high resolution of the model. So let me show you what the Weather Service is saying, which at the end of the day, they are the experts. They produce the best forecasts. So just even before that, let's look at what's up. We have winter storm watches that are up from about the Virginia mountains, West Virginia mountains, up through western Massachusetts, southern Vermont. So the Weather Service put up the watch for these areas that are northwest because they're gonna get some decent snow out of this. That is warning criteria level, regardless of a northwest track or a coastal track. The idea is the areas along I-95 and just to the northwest of it, are we going to get a decent amount of snow or not? That's why the watch is not up yet for those reasons. Now, what I'm thinking is that this forecast looks pretty good to me, I would say right now, from the information we have. Around 6 inches I-78 north and NJ. And just if we take I-95, go north and west of that, again, the 6 inches line is north and west of I-95. I-95, we're thinking maybe 3 to 4 inches of snow. And then northwest, easily 7, 8, potentially even 9 inches. And coast is maybe around an inch at best, inch to 2 to 3 basically. Now look at the high end over here. This is if we have more of a coastal track. We're going to get 8 inches plus north of 78, and areas of Pennsylvania, even 10, 11, 12 inches, not out of the question. And I-95 would be getting around 6 inches of snow with this, which would be pretty good. Now, I think that this forecast with potentially higher totals in the northwest as of right now is what I would think is best. Like maybe put like 9 or 10 in Mount Pocono. Same thing with the mountains in northern Jersey. Because what I'm thinking is we're going to have a northwest trend with the storm. The storm, because this is generally what happens in experience. The storms that are being depicted on the models, they tend to trend northwest. Now the issue here is that our solutions are split between like very far off the coast to coastal to northwest. That's the only issue we have with our models here. It's not like all of them are coastal and then they all could shift northwest. It's just that one of them is going to be correct. We just got to see which type of track plays out to actually refine our snowfall forecast. So I would think for a preliminary forecast, this forecast, brilliant, just maybe a little bit higher in the northwest, because I'm thinking as we get in those regional mesoscale models, there could be some banding that sets up, especially across the northern areas as the low pressure strengthens. But again, the biggest question is what kind of track this storm is going to take. That will determine stuff. Just to show you the low end, this is the low end. If we get a European type situation, this is definitely a reality. Like only 1 to 3 inches across the entire area. So yeah, that is my preliminary forecast. It is to be seen how it plays out with the track of the storm. So this forecast will definitely change. All right, thank you.